In this video, we're capturing the topography and volume of a stockpile to calculate how much material needs to be removed from site. We begin by measuring the perimeter of the stockpile. Before starting, points A and B are set out on site using orange cones. These mark our starting points and will come in handy later when aligning the volume layer. As with any perimeter measurement, start and finish at the same point and use good measuring technique focusing on pace, placement and rotation to ensure the best results. Once the perimeter measurement is complete, make sure the file is saved in the app so a new layer can be added. On uneven terrain, using the Moasure device without the stick allows it to settle directly on the ground, helping it remain stationary and improving pause point accuracy. With the save file open, select Layers, then tap Add Layer. When a layer is added, the app displays the A to B reference route showing the edge used to align the volume layer with the original perimeter. The orange cones mark our A to B reference line, which we'll use to align the volume layer with the original perimeter. Return to point A, then walk toward point B. A black guideline appears on screen to help you follow the same reference edge. Once the A to B reference walk is complete, the app switches to Ignore line, allowing movement within the perimeter without changing it. At point B, change the path type from Ignore line to Points. The Points path type allows you to place individual elevation points rather than following a continuous line. This creates a new reference point, point C, at the same location. This is the point you'll return to when finishing the layer. Using this location works well here as it sits on flat perimeter ground before the grade of the stockpile begins to change. With the points path type selected, begin capturing grade and elevation changes across the surface of the stockpile. As you move away from point C, a checkered flag remains visible to remind you of your return point, and a dotted line shows the path taken so far. Work across the area in a spiral or a zigzag pattern, placing points wherever the height changes. Flatter areas require fewer points, while slopes, peaks and dips benefit from more detailed capture. Once you've finished collecting data, return to point C and capture your final point. This closes the loop and helps keep the layer properly aligned. Tap the red stop icon to end the measurement. The 3D mesh view shows the triangulated surface created from your captured points, along with the calculated surface area and volume. The 3D contour view shows the same surface using contour lines, which help visualize height changes and slopes across the stockpile. At the top of the screen, you'll see two volume calculation options, lowest point and perimeter. These determine how the base of the material is defined. The lowest point plane uses the lowest captured point as the base of the volume. The perimeter plane uses the height of the outer perimeter as the base. Because this measurement is focused on material being removed, we select the lowest point plane to calculate volume. To estimate how much material needs to be added or removed, tap Edit, then select Cut Fill. You can enter a specific value or adjust the slider to see changes in real time. For a more detailed breakdown of Moasure's features, visit the user guide. If you need further help, you can send a support request directly through the app, and a member of the Moasure team will be happy to assist.